Very good. Well, we will move right into our operations update. We have Ellen Ford, who's Deputy Chief Operating Officer for the lab. Normally we have Michael Brandt, but he's, I guess, on a trip, a business operation. So we will proceed with Ellen, and then from there we'll go on to a series of presentations here about Cyclotron Road. And I would just note that was a talked about idea for this coming year for 2026. The year we're now in, we were having our November meeting and asking about potential topics to feature during this year. And so we're starting off with Cyclotron Road this evening, and we'll get into that here momentarily. But let's first hear from Ellen regarding an update on operations at the lab. So, Ellen, it's all yours.
All right.
Actually,
Well,
if you don't mind stopping your screen share, I will pull up Ellen slides. Awesome. Thanks, Daniel. Alrighty,
all
here
right. Good
we
evening,
go.
everybody. It's been a while since I've been to a CAG meeting, and I think I've met most of you, but it's good to be here tonight. Yeah, as Daniel said, Michael is traveling to DC, and I think he probably just landed, so he wasn't able to make it tonight, and asked me to give you all an operations update of what's happening at the laboratory. So, maybe next slide, Jen. Jen's helping me. She's my friend tonight, helping me with slides. So we'll talk a little bit about what's happening with the budget and the update there and how that's impacting the laboratory. I'll give an infrastructure and facilities update. Tell you a little bit about what's happening with the new lab director search and where that stands, and then kind of a feel-good moment at the end about our winter food bank results. So we have a competition each year. Talk a little bit about that. So as far as the government budget goes and its implications for the laboratory, so I know that Michael met with you before the holiday break. There was a lot of uncertainty. There continues to be, but things that seem to be moving in the right direction. Back in the summer and fall, we had planned at the laboratory to do some reductions in force, mostly in the operations area in preparation for what we thought would be fairly deep funding cuts for research. And so we sort of had this balance that we had to do of, we wanted to do some cuts, but not too deep, and wanted to be able to wait and see what would happen with our research portfolio. So last week we learned that the House and the Senate Appropriations Committees released a three-bill fiscal year 26 package that included their compromise position on funding for the Department of Energy. So it was actually positive news. The bill includes 8.4 billion for the Office of Science. That's a 1.9% increase of what we thought it would be. There is a 10% decrease for energy efficiency and renewable energy. It's down to 3.1 billion. But the good news is we thought it was going to be 40%. And in general, when we look at sort of program by program, it doesn't go too deeply into programs, but most of our priorities were funded at levels that we expected them to be. So we are not anticipating at this time that we would need to do more cuts. There may be isolated cuts in certain programs, but I think it would be very limited going forward. So next slide. Okay, so a little bit of infrastructure update here. So right now, so what we are calling Collaboration Commons, our Welcome Center, is really evolving. Up in the top left, I think you've probably seen this image before. That's it's envisioned to look like. In the lower left is where it was in November. I think you saw at the last CAG meeting, and then where it currently is on the right. So that white skin that you see on the building is really to help weatherproof it. But as a reminder of what's going in here, so cafeteria is one of the things that we're very excited about as a laboratory community. But it's not just that, it's a conference center that'll have a lot of meeting spaces. We're putting our health services center in there, and we're also putting security services in there. So badging. It will also have a transportation hub unit, which so it really will effectively be a welcome center for the building at the heart of our campus, and we're very much looking forward to it. Right now, it's scheduled for planned opening in the spring or summer of 2027, so it continues to stay on schedule, and we're really excited about this for lots of reasons. I actually have not, and it's made a lot of progress recently. I haven't seen it since a couple of months before. I haven't done a tour since a couple of months before the holiday break. And I'm going to be going on a tour on Wednesday. I understand it's made a lot of progress. So that's exciting for us. We're very much looking forward to that and are happy with the way that it's progressing. Next slide. So another project that we have going is, you'll remember that the Centennial Bridge was replaced, and that was an investment by UC as well. Was managing that project. So right there where that new bridge was put in, which really was seismically needed, we had the Department of Energy had funded us to upgrade our Strawberry Gate. So that's the gate that's right below Centennial Bridge on Centennial. And it really gave us, with the renewal of that bridge and then moving the bridge over, it really gave us some more room to be able to make that a much safer entry for our employees so that cars wouldn't get as backed up. And it's enabling us to really, make that more of a state-of-the-art um, entrance to the laboratory. So that's been an ongoing project. You can see what it looked like on the left, what it currently looks like with all the scaffolding, but we started work on it in November 24, so it's been over a year. And we're right now, it looks like we'll be opening at some point in February, mid to late February. And we're excited for that to happen. And the people who work on that side of our campus are very excited for that to happen so that they don't have to come in through Blackberry or Grizzly and make their way over to that canyon. Next slide. Okay, so let's talk a little bit about the rain. So I believe in the last CAG meeting, Michael had talked about how we had some blocked storm drains. So this is sort of right above where the Greek Theater is, below our big horseshoe parking lot outside of the gate. There were some clogged drains there. We had a big overflow. That was then fixed. So they fixed the drainage situation. They replaced all the wattles there, and put in more effective drainage. I think Michael might have reported in the last meeting that it worked, that we had no issues with the last rains, but we've had a really unprecedented amount of rain in this last couple of months. So, we've had 17.86 inches of rain between October and January 7th. So it's a lot. It's 148% of normal. We know this because we've got a weather tower that's right above the ALS, and we take measurements. So it's been holding, and unbelievably, we had that huge rainstorm that felt like it went on for days and days and days, because it did, at the end of the year and the beginning of this year, calendar year. And we had one roof leak. That was it, which was really kind of amazing. I think that might be a record for the lab. So we're pleased that those improvements are continuing to hold on. So now I'll talk a little bit about the laboratory director search. So Mike is planning to leave in June of this year, and a search has been ongoing for his replacement. And we had what we were calling Lab Day, and that was on December 9th. And that's where UC President James Milliken came, and he came with the Search Advisory Committee. So that has members of the UC Regents, faculty members from campus. Berkeley Lab scientists are on that committee, and there are other UC leaders that are on that committee. And so they visited the lab. They spent a full day, and the purpose was really to meet with, we have 6 areas at the laboratory of research, and then there's the operations area as part of that as well, to really meet with leadership at the area lab director level, as well as the division director level, to understand, what it is that would really help the laboratory. What are the qualities that we would really want to have in our next leader? Mike has been just such an incredible leader for the laboratory and helping us really, stay on track with the mission. And so they had very in-depth conversations. I think it was a long day. There were a lot of people that sort of cycled through that meeting, but I think they really learned a lot. And right now they're hoping to have a recommendation sometime during the spring, or early summer, for the regents to consider. Next slide. And then this is just we wanted to say a little bit about our Winter Food Bank Challenge. So we've been doing this for the last 6 years, and it's raising money for both Alameda County and Contra Costa County food banks. This year, we were able to raise almost $160,000. And so in the last 6 years, we're coming very close to 1 million, which is really, really exciting. And since that, since the inception, it's really equated to being able to provide 1.8 million meals. So we're very proud of that. It's something that we're looking forward to continuing as a tradition at the lab, and wanted to be able to let this forum know about our progress there. So that's everything that I had. Any questions for me?
Excellent. Thank you very much, Ellen. We have plenty of time here. We're moving well on our agenda. So, Marcos, did you have a hand up?
Yeah, so I mean, we get rain totals for the Bay Area and things of that nature. In my neighborhood, we're up on the hill. We don't have a really great way of translating like what our rain totals are versus what we get on the hill. So, is it easy? Do you guys have like a percentage that you maybe know about, like relative to the flats and the recorded number for the city versus what you get up on the lab? And is there a delta that's pretty
I don't know
consistent?
the answer to that question. I mean, we could certainly find out and see what they're tracking. In addition to, what sort of, comparisons they're doing in addition to what we get at the laboratory. But I don't know the answer to that, but I could certainly find out.
Okay, yeah, because it's one of those things that's like if it's linear, it's not such a big deal, but if it's non-linear, we're noticing like some of the as we come down through the hill, the if it's non-linear and the delta's non-linear and it spreads wider during certain part of the season, we are noticing like certain areas just kind of get really over inundated below our hill. And I'm
Yeah,
just wondering if you guys see something of similar of that nature. And we're interested in trying to help control and find those mechanism stuff. But it's difficult to kind of go off of when you see the total down there and then you've got a bucket out in front of your house that's like 4 times that amount or five
right.
times and that's something that a lot of people here are kind of interested in.
Okay. Yeah, we could certainly take a look at that and report out next time.
Thanks.
Okay, great. Thanks, Marcos. Any other questions, comments on Ellen's presentation?
So if
Okay.
there aren't any comments, I just wanted to jump in really quickly. And Ellen, I hope you don't mind me saying this, but Ellen has been with the lab for 24 incredible years. She is sadly retiring in March. And while I'm super excited for Ellen, I'm not sure what the lab is going to do without her. She's been
Oh,
just an incredible person to work with. And I just wanted to say thank you to you for everything that you've done over the last
All
24
right.
years for the lab. So, yeah.
thanks. I
Thank
mean, I
you,
have to
Ellen.
say, the lab, I feel so fortunate to have had the opportunity to be able to contribute to the lab's mission over these last 24 years. It's been an incredible experience, and I'm grateful, and it's very bittersweet for me. So I'm glad this meeting is happening this week and not last week, because that was when I announced, and I might not be able to get together right now if it were
Great.
lucky.
Excellent. Well, it's fortunate that you were able to fill in for Michael and we get to see you as you are preparing the next stage of your career. That's great. Thank you. Okay, well, we'll move on to our next presentation then. Melanie Sonsting is the program manager with Cyclotron Road, and we're going to feature that topic this evening. So let's go to Melanie. Take it away.
Hello, everyone. It is a pleasure to meet you. This is my first time getting to visit the CAG meeting. My name is Melanie Sonsting. I'm the program manager for the Cyclotron Road Lab Embedded Entrepreneurship Program. I understand that you had a presentation on our program back in 2019, so some of you might be familiar with this, but I'm going to do just a high-level overview in case anybody wants a refresher or wasn't able to be at that past meeting. And so I'll share some slides, but before I start that, I'll just give you a little bit of information about my background. I'm a Bay Area native. I grew up here in San Pablo and then Pinole, went to school at UC Santa Cruz, and came to Berkeley Lab around 2004 for what I thought was going to be a gap year before I went on to do maybe some counseling or social work was sort of what I was interested in originally. But I fell in love with Berkeley Lab and the lab's mission, and especially the people that I met at the lab. Super inspired by the scientific work that the community does. And so I stayed on and have slowly been working my way through a number of different operational support positions, starting at the Material Sciences Division, moving on to support some of our other hub-based programs. You may remember the Joint Center for Artificial Photosynthesis. And so I've been really fortunate to be involved in some of the startups of some of the new initiative programs happening at the lab. So in 2015, we had a pilot program that we called Cyclotron Road that started, and I got to join the team when it was first just a few people on it. And I'm the person who's been with the program for the longest. So for the last 10 years, I've been with the program. And it's just been a real pleasure to have my career grow alongside such an amazing program. So with that, let me share my slides. Okay, and do a slideshow. Does that look okay to everybody?
Went through. It's
Okay.
good.
All right, so Cyclotron Road, which originated as a pilot program, it is a program that is designed to take early stage hard tech startup founders, embed them at the national lab, providing them with access to our facilities, our expertise, and in most cases, DOE funding, but sometimes some additional funding sources from some of our partners. And we've had the DOE partnership since the first year in 2015, but the program would not have gotten off the ground without really phenomenal belief and leadership from the lab directorate in helping to also give some seed funding to pilot this program. And in the last 10 years, the program has been successful enough that not only are we continuing to go strong and have a very vibrant alumni community, but the program has been duplicated in a number of different sites at other national labs and in other community areas. So there's been a lot of validation for this model for embedding startup entrepreneurs that need hard tech support at a national lab and beyond. So there is a website there that I can drop into the chat before we leave the program, or if Jen wants to drop it in there. If you want to see a little bit more breadth of what our alumni participants have done over the last 10 years, you can read up on the various fellows and their technologies. My hope is that you are going to get to hear from two of our current participants today. I know we have one of them online. One of them, I've told her we are ahead of schedule, so she'll be joining us too, hopefully. And so hopefully you'll have some questions for them. They're really been making great strides in their technical progress, as well as growing as entrepreneurs and leaders. And that's kind of one of the secret sauce elements of the program. While we are focused on connecting these participants with technology support, and we are hoping that their technologies that they're trying to commercialize are going to be fruitful and have the impact that people may predict that they'll have. The true specialness of the program that we found is that it is helping to train scientific researchers with the expertise to tackle these technology problems, to become stronger leaders, to take the initiative in our society to try and tackle these problems, even if they started on a small scale, hopefully giving them the support through programs like this one to really get some traction and move forward. And if not in the technology that they join this program, then hopefully their leadership skills will allow them to make an impact in whatever their next project is. So started out with the founder, who was Alon Gore, had come out of his graduate and PhD studies at University of California, had been at Berkeley Lab, went off, founded two battery companies, had a lot of experiences in how that doesn't work so great with a lot of the resources that were available at the time. And then picked up a position at the time newly started ARPA-E program, and really got to see what it was like if you could put government resources and funds behind some of these promising technologies, but he still recognized there was a gap. People that were eligible for the ARPA-E usually were later stage, had a more well-established company, and he saw, along with a number of other colleagues in the DOE and at Berkeley Lab, that there was this population of people that potentially could be led to become technology entrepreneurs who were instead, because of lack of resources and a lack of a path to do that, were instead going into other parallel fields that maybe wouldn't have as near-term an impact as they might otherwise hope. So the experiment was the Cyclotron Road program, which became the Lab Embedded Entrepreneurship Program. It's to facilitate the translation of hard science into positive societal impact, and hopefully to allow these innovators to bring their technology forward to a viable first product. Part of the storyline is that as we stood up this lab embedded entrepreneurship program, LEAP, we also discovered that there were a lot of things that we would like to offer these early stage innovators that national labs don't excel at. And so very early on, we partnered with a nonprofit called Activate, which is also headquartered in the East Bay in the Berkeley area. And they have become a keystone partner in that they run a parallel 2-year startup innovation fellowship program that's hand in hand in ours. So we've built our programs alongside each other, and we, for the most part, support the same innovators at our Berkeley location. So I'm sure you're all well aware of this being part of the CAG, but the Berkeley Lab has a lot to offer these innovators to attract them to want to join Berkeley Lab as a place to move their technology forward, including the 5 DOE national user facilities, additional unique research centers, and a lot of just phenomenal expertise. So what our program does is we try and help curate all of the resources, which can be sometimes hard to navigate for people that aren't familiar and already embedded within the lab. We give them a 2-year time frame, and we work to help them if they're interested in a user facility to help and help them engage with those facilities, as well as other principal investigators at the lab that may not normally work with external companies. We will help do a mentoring matchmaker depending on the company's needs and the interests of our PIs. And what the program offers with support both from Department of Energy, Berkeley Lab, and our nonprofit partner Activate is a 2-year fellowship. So it's not an incubator or an accelerator, although sometimes people call it that, and there's overlap in those offerings. We call it a fellowship because we want people to come into the lab and put all of their time and their effort into this particular project. It's not meant to be a short-term temporary stepping stone. It is meant to be a very high-touch, integrated and embedded 2-year program that's both going to help them move their technology forward and provide them with the resources to become an entrepreneurial leader as well. So they get up around $100,000 per year in a stipend. And then travel insurance, health insurance, relocation funds. The idea being to level the playing field on who can be eligible for the program to try and reach as many potential hard tech entrepreneurs as possible, and make it so that they can focus on this project without having to have either existing funds of their own or another full-time job while they're doing it. We connect them with both the expert scientific community at Berkeley Lab, as well as our regional partners such as UC Berkeley and Silicon Valley folks, and a lot of the other innovation support systems that we have in the Bay Area. We also connect them through Activate with additional state and federal funders and contacts, as well as philanthropic and regional supporters. So we're trying to be able to reach the widest array of innovators and technologies as possible. And we found that by having this sort of connected across various organizations, we were able to build a pretty robust network for them so that as things ebb and flow each year, we're able to try and meet as many people's needs and get the best innovators into the program. That said, it is a very small program. We only support about 8 to 10 new fellows per year. The reason we've capped it at that is because we found that that was the highest number that we could support each year and still have the high level of connectivity, mentorship, We do quarterly board meetings with them. We do weekly content programming. And so, in order to have the level of dedicated, sort of bespoke support for each of them, we want to keep that number small. We also have some diversity built into it across it's not just the one cohort going through 2 years, they overlap by a year. So each year, one cohort is graduating, one cohort is halfway through the program, and one cohort is coming in. And that connectivity has allowed the alumni group to really become an unexpected strength of the program, where they're not only able to tap into the other 8 to 16 people that are going through the program with them, but potentially, 123 people that we've supported over the last 10 years. So what we have found is that this fellowship works. Since 2015, as I said, we'd had 123 fellows come through the program who have founded 92 science-based companies. And just recently, we surpassed the 4 billion metric in the company's follow-on funding. So what we're finding is that companies that get into the program and complete the program continue to be successful to a large degree once they leave the program. And the societal dollars into the program are heavily leveraged in a positive way with these follow-on funding, with belief in these companies and the impact that they're going to have. Once we saw, and the DOE saw, that this was a really viable path forward for some of these, that we had very positive feedback from the participants and from the community that was helping us support them, the DOE decided to expand the model, and there are now 3 additional laboratory embedded entrepreneurship program, LEAP, at 3 other national labs. And I have to update this. I know that some of our names have changed. But we have at Argonne National Lab, at Oak Ridge National Lab, and the National Lab of the Rockies. So I will share these slides with Jen to be shared out with you afterwards. And if you want to visit any of those sister sites, we work closely across the 4 national labs that are supporting these innovators. And we found that to be a really strong point for the program also. And then on our nonprofit partner side with Activate, they founded their initial fellowship program in Berkeley alongside ours. And they too had the same goal, where they want to make the greatest impact as possible. And their program is modeled after the exact same format that we have. And so, in order to reach more people, instead of having larger numbers in each program, the model has been to increase the sites that it's at. So while the LEAP programs, such as Cyclotron Road, are always embedded at a national lab, only the Activate Berkeley fellowship program is partnered with us at a national lab. They have an additional 5 sites. 1, 2, 3, 4. Yeah, there's a new one. 5 sites that are regional partners that are not national labs, but some of the participants in those other states also access national labs or universities, et cetera. So we're trying out a number of different models. The experiment continues. We found different things work better in different communities depending on what resources are available, and we continue to grow. And we are really looking forward to hoping to see another 10 years of Cyclotron Road and Leap. I
Okay.
will stop sharing with that. And I'm happy to answer any questions. While I also want to make sure we give a little extra time for my next speaker to come on. She said she's going to come on soon. So please let me know if
Okay.
you have any questions.
Excellent. Thank you very much, Melanie. We're certainly on and ahead of schedule, so no problem with
And I see
that.
she's here, so we're good.
Yep, I do see her also online. Any questions or follow-ups for Melanie about cyclotron road activities? Okay, Marcos, go ahead.
All right, simple question and maybe a little bit of overlap for Ellen. So how much of when you're going through, so in the last decade we've been also witnessing like a change of the dynamic from the executive branch in terms of funding. I mean, how much is this a part of the picture that is the sell for the labs to like increase funding, or where research can kind of expand? I mean, this is a question for either you, Melanie, or Ellen. Is like is this incorporated when we're kind of like trying to do the sell pitch for the lab and trying to gather resources? I mean, it seems like it's a great way to kind of establish that like moving forward, we got a growing program that's actually bringing in leverage and expanding capitalization, which is what a lot of what people want to see out of current administration.
Well, I can start just by addressing it from the cyclotron road, point of view. Can't speak for the lab as a whole, but I can say that our program has continued to be really well supported throughout the last 10 years. The innovations that are coming through are ones that are very popular for potential solutions to common um, issues that we're all finding. And so there's just been a lot of celebration of it. And that we've seen that across the DOE offices. And so we're hoping that that will continue to be a highlight and a selling point for our lab and the other labs that have LEAP programs.
Yeah, so I mean,
Mm.
Cyclotron Road was really the first program of its kind, and inspired really the spread of it across the complex. It's not at every single lab, but it is at other labs as well. So I think it's been very, very successful and very well supported.
Yeah, I'll just add, we've and my colleagues have done this currently since I'm not doing federal relations anymore, but we've brought a number of Cyclotron Road fellows to Capitol Hill, and members in both the House and the Senate, both sides of the aisle, have really sort of understood the value and the impact of a program like this. So we continue to receive really strong support from folks on the Hill.
I got to
Mm.
participate in that this year with Jonathan Nurse and a bunch of the
Nice.
fellows,
Yeah.
and it was so much fun. It really
Yeah.
was invigorating to have so much support.
Okay, any other questions or follow-up items? I did have just a question, Melanie. There was Activate Boston, Activate New York, and then there was Activate Anywhere. What was that one referring to?
Yeah, so the model, while the programs offer almost the same kind of overview template of what we want to offer the fellows and how we do it. There is the difference where Activate is really focusing on the entrepreneurial support, whereas the LEAP programs are really focusing on the technical mentorship and technical support. And so as Activate has expanded out their communities, since they are not heavily embedded in one particular physical institution, but they're allowing their other non-Berkeley participants to sort of choose their
Hmm.
own support areas. They determined, well, in addition to having these regional hubs, we should probably have a Activate Anywhere remote community, which allows people that are maybe trying to commercialize in smaller rural communities in states that don't have access to large laboratory infrastructure. It kind of spreads out that ability again. And so it just gives more options to the innovators to sort of choose their own adventure and how they're going to move this forward.
Okay, all right, that answers that. Thank you. Any other points for Melanie?
I'm just going to shout out
Well,
Melanie actually really quickly, who is missing a class this evening to actually give this presentation. So thanks, Melanie, for making the time to do this.
Yeah, it's
all
fun.
right, thank you. Again, thank you very much, Melanie. Appreciate your presentation this evening. Thank you very much.
All right.
So
Well, with
we
that,
will move,
may I
yep,
introduce Carla?
yes, go ahead, please.
Okay,
Let,
sorry to step
let
on your
Jackie
toes
do
there,
that.
Daniel. I would like to introduce our fellow Carla Pinson from Expand Power. She is one of our teams that is halfway through the program, so she's been in it a little over a year and still has some runway ahead of her. And I know that Carla is feeling maybe a little bit under the weather, so I don't know if you're going to share your video. Yay! Hi, Carla. So good to see you.
Hi.
I will pass the mic
Hello,
to you
welcome.
to introduce yourself and share your screen. Thank you so much.
Sounds good. Thanks, Melanie. Um, okay. Can everyone see my screen?
It's coming up. Yes, we can see it. Good, looks
Okay,
good.
awesome. So as Melanie said, I'm a current fellow of the Activate program. My name is Carla Pinzone. I'm also the CEO of Expand Power, where our vision for the world is to have a distributed, resilient, decentralized grid that we want to push through using new types of power electronics and something called a solid state transformer. So I'll start first by just talking about my company, and then give a little bit more context about how the company was formed and how valuable the Cyclotron Road program has been. Um, sorry. So we're at a really crazy time in the world of electrical infrastructure right now, where the the prices for transformers have increased at least 80% in the last few years. Data center growth is ridiculous and at levels that we couldn't have imagined. And we installed over 500 gigawatts of DC and inverter-based resources on the grid alone last year, which if you had asked us several years ago if this is what was going to happen, we would have laughed at you. So really an unprecedented time where we're hitting this inflection point, and there's many new sources and loads in the grid that we couldn't have imagined. And we just simply don't have the power electronics and the infrastructure to really keep up. The grid that we need looks fundamentally different from the grid of today. And it's a very scary issue to be in, very scary world. The transformer is the most critical piece of the grid. This is the transformer. You might have seen it outside of a Walmart, shopping center, outside of a factory or a data center, for example. The technology hasn't changed in decades, in centuries, really. It's just a piece of metal immersed in oil with wire wrapped around it. So it's really not suitable for this inflection point that we're starting to see for a few reasons. First, they can only do AC, so they can't do DC power that you would expect in like your Tesla or like a data center or like a solar field. You also can't control them. Utilities only know about these transformers breaking because they'll get a call downstream from you, like the customer, being like, hey, where's our power? Which is insane in a world where we increasingly have the ability to monitor and understand assets. And on top of that, you just can't get these transformers. You used to be get them in a few weeks, and now we're seeing lead times of over 2 to 3 years from China or Korea or other places that might have national security and national energy implications. So many issues that we're seeing with these transformers. And our technology and the company that we're building essentially aims to solve these issues. This is what our first product would look like. We're building something called a solid state transformer that takes away all of these major pain points. So first we can do both AC and DC. So we can provide load to like your standard house, but we can also provide power to like a data center or a solar farm. Everything that needs power, we can provide. At the same time, we have a dynamic operating range, so we can change how the transformer operates. We have smart monitoring. We can actually understand when it's going to break before it happens. And there's a lot of value in being able to understand what's really happening with it. And the last part is that we can manufacture it domestically in the US using a well-established supply chain. So we do all of that using a proprietary technology, which is a combination of a system design, new type of semiconductor device, high frequency control schemes, and proprietary magnetics configuration. This technology can be used not just for sort of the obvious ones that I mentioned, like solar, data center, utilities, but for defense applications, electric boats, mining, off-grid. Really, the sky is the limit as we start to see newer and newer types of power electronics on the grid and in every single world, or every single piece of the world that we live in. That's me. We have a wonderful CEO and a really, really amazing team full of power electronics experts, utilities experts, previous founders with a lot of experience pushing first of a kind technologies out in the world and seeing their impact. So now that I've talked a little bit about like why are you listening to me and what are we building? Um, I'll talk about our trajectory. So my background is in power electronics, electrical engineering. I did my undergrad and my master's at MIT. Um, I had been exploring modular power electronics while I was there, and I decided to do a PhD to see if there's anything that I could commercialize. So I started a PhD at Stanford, moved to the better coast. Um, while I was at Stanford, I led a team for this entrepreneurial class and realized that what I have been working on and thinking could be really, really beneficial for the grid, for transformers. And so I dropped out of the PhD. I got a job to bootstrap myself at Sonos. My first full job out of college, I was a lead power electronics engineer. And I did that really just so I could bootstrap this company, like what is now Expand. But it's really difficult to work two jobs. and I wasn't really working too much at Sonos because I really wanted this company to succeed. So I applied to the Cyclotron Road program twice actually, because I saw it as a way to dedicate myself completely to my company, to a problem that's so important that needs my full undivided attention. And then the second time I got in. So without Cyclotron Road, without this fellowship program, there would be no company. There'd be no expand. Uh, and this problem is so important that affects so many aspects of our life. It's crazy. We need so many people thinking about and working on it together.
Mm.
And just so you guys could see, I mentioned that I was working on this while bootstrapping myself while I was at Sonos. This was pre-Cyclotron Road Expand. It was our lab in the guest bedroom of my 500 square foot apartment in Boston, which was I'm not sure my landlord was too happy with me experimenting on high voltage, high power supplies there. But very limiting. Just nights and weekends. I had no money. Progress was so slow. Investors were like, "We're not going to take you seriously because you're just some person working on your spare bedroom." The really completely different ball game compared to what actually Cyclotron Road provided, which is this living stipend, focus, so much more progress technically, actually
Mm.
having the runway and the cash to do something and to make prototypes and to feed myself and to pay employees, so much more credibility and investor interest. We went on to win the American Made Solar Prize, the DOE Epic White House Pitch Competition. We have two extra teammates now. We got into some accelerators with utilities. We built our second generation prototype. And we've developed a community and relationships of other founders and mentors who have now become either partners, really strong advocates, or angel investors. So for me, this program has been very life-changing. Can't speak
Mm.
highly enough about it. Without it, I would still be doinking around in my lab trying to get something off the ground and running. So it's really hard to start a company, especially by yourself, and use as many resources as possible to help is exactly what we needed. So yeah, big fan of the program. Can't say enough about it. Has completely changed my life and set our company and our mission on a very uh, important path. And I think I'm over time, so I want to make sure I'm respectful. But yeah, open to any questions about the company, about the Cyclotron Road, whatever is most helpful.
Fantastic. What a great story. And you're living this out right here in Berkeley. We're really excited about that. So let's see if there are any follow-up questions for Carla. Any responses, ideas, new potential leads on new products to explore? All right. Go ahead, Marcos.
Right. Just a random question. Because I'm a landlord, I'm always interested in what's kind of going on around me. We've housed students in the past, and we really enjoyed their company and things of that nature. But it was interesting that you mentioned that, housing and you're starting. How difficult of a transition? How is the lab or the program accommodating that differential or that delta from coming from different regions and being able to have people housed here? I mean, this is a really tough environment for people to transition to. Was that a big portion of it, or was it kind of taken care of by the program?
Well, for me, it was really just having like I was only at Sonos, so I could like feed myself. And so for me, the biggest benefit of the program is that it gave me something to live off of. And it wasn't just like a stipend, like it was like a pretty good stipend for the Bay Area. They also gave us a relocation amount, so that was enough for me to move like me, myself, my all my boxes of stuff that I hoarded and probably should have gotten rid of years ago to the Bay Area. And on top of that, the lab space that Cyclists Remote has provided has been really, really beneficial for us too. Like they have a lot of the equipment that we need. Just having a space is really cool to show investors or potential partners. And having like the technical staff as well to like bug and like take advantage of their resources as well, if you're nice enough to ask them, has just been really, really beneficial. I think that uh, the fellowship program goes above and beyond in what they offer to make it like a like ridiculously simple yes to take.
I find that really encouraging, and I just think that that's something that if somebody's starting a program that they can overlook, is that the delta of coming here to the Bay Area and being able to hit the ground running, it's really difficult, and mainly because you off research of what you want to do is going to be just as difficult as finding the proper space to do what you want to do, expand where you want to do, and to make that comfortable. Just want to, shout out to the program because that's a
Yeah.
difficult piece to manage and to incorporate that. It really takes a lot of thought, and a lot of thoughtfulness because we are people and we're not machines. And it really makes me feel good. I see a lot of positive energy coming from you when you're telling your story. It's really great.
Yeah, I mean, for me, it's been so life-changing that I'm always excited to like tell other people about like my story and the program because uh,
Mm.
when I look back about who I was like a year and a half ago and who I am now, and just like what this company has become, it's such a noticeable inflection point. Um, Yeah,
Mm.
I don't think that my company would have made it without the Cyclotron Road program. Like there was just so much resources and like mentorship and community that I needed to like learn and experience that the program provided, and it's just been yeah, very, 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 very positive. I especially like the community that Cyclotron Road program has set up has been really valuable for me. Like I bug Patricia all the time for random stuff, and she's always been very helpful. And it's the same with like all the fellows. They've been through it, they know how hard it is, and they're always willing to give back and to help the next generation.
Mhm.
I just think
But
that's
so
awesome. That's awesome.
it's so interesting to get the insight from someone such as you as a fellow and your experience and the transformation that you're able to bring about as a result. Thank you. So Sarah has a hand up.
Hi, I'm Sarah Moore. Oh, sorry. Can you hear me now?
Yep,
Sarah
you're
Moore.
good.
I work for the City of Berkeley. I'm in our planning departments in our Office of Energy and Sustainable Development. So thanks so much for sharing what you are working on too, because it's super exciting because I know firsthand that our own city projects have had issues with transformer delays, and I know we hear in the planning department about private developments that have
Oh yeah.
issues with transformer delays. So I know this problem is very, very real. And super excited to hear that you're working on an alternative. So I don't have a sense of like, are others working on this too? Like how close is this to like are you working with PG&E? Are they supportive of these efforts? Would just
Yeah,
like
we have like several letters of support from like very big utilities like Duke Energy, we've
okay.
been speaking to SCE, like Southern California
Hmm.
Edison, Duquesne Light, Tucson Electric Power. PG&E we actually haven't spoken to.
Okay.
They haven't, they just haven't like popped up. Doesn't mean
Hmm.
that they're not interested in this. Our
Hmm.
focus has shifted more recently from utilities to data centers and developers, just because they're
Okay.
so much easier to sell to. Um, Today we actually signed a letter of intent for like $6 million, which is a really big deal for us of units that we're going to procure for this potential, or we're going to build and make for these potential customer.
So you
So
are to the point of making units for customers.
we're like just before that. We'll pilot it first and then we'll
Yes.
make the units for them.
Awesome. Awesome.
Yeah.
And I didn't quite catch your email. It was on the screen a
Yeah.
little too
Let me
briefly,
let me
but I
share
would
my
love that.
yeah, always
You could,
very very oops, can you guys see it? If anyone wants to talk more about transformers or use cases or anything about starting a company, like an investment cycle, partnerships, whatever, we're always very, very open to it.
Thanks so much. Really appreciate
Yeah.
your sharing.
Yeah, and Carla, maybe you could put that in the chat as well. That would be excellent. So people can refer to it. Or maybe hook you up with a potential customer. Who knows?
Yeah, I would
Oh,
appreciate that. Thank you very much.
okay. All right. Were there any other follow-up questions or comments? Again, let's give Carla a round of applause for her presentation and her efforts to bring about a whole new company, a new product solution for the energy grid. So we will go on to the next presenter, Dr. Patricia McNeil, who's also a Cyclotron Road Fellow and is the CEO of Westward Aerogel, if I'm pronouncing that correctly. Okay,
Westwood
why don't
Aerogel.
you, all
Yeah, yeah.
right, take it away. Go
Oh,
ahead.
thank you. Also, riffing off of a little bit what Carla said, one of the big advantages I feel like with the Cyclotron Road and Activate programs is just the fact that like this is a community of innovators who are doing real hard sciences. Because you see a lot in the Bay Area, it ends up being more like things software or AI, and it's just a whole different ball game. You're approaching struggles from a different mindset, and the way that you think about scaling technologies and the types of things you need to worry about as you scale a technology are very different. So that's something that I found extremely valuable, both looking to like the mentors within the community, the cohort that was right above me, as well as looking to, share my information with folks like Carla, who are right before me, below me, and for me, that kind of also like solidifies that I know what I'm talking about because then I can basically reiterate that information to Carla, and then you can reflect on that and be like, oh, I learned something. This is good. The program works.
Yeah, the peer-to-peer support has been phenomenal. I love seeing that happen.
All righty then. I will pull up my deck. Unfortunately, it's like built off of my current investor deck, so it's not as fun as I would necessarily like, but we will proceed. So what my company focuses on is hold on, let me make sure it can actually flip. Cool. The scalable production of aerogel. So aerogel has historically been considered a very high value but high cost material. So aerogel is above 90% air, and it is the lightest and most insulating material on Earth. It's been previously used in many aerospace applications. So you're thinking things like Mars rover, Mars Pathfinder. But the reason why it's not more ubiquitous today is because it is incredibly expensive to produce. And if we can drive down the cost of production, what you would then see is an opening of opportunities, including things like the building envelope. So you're thinking things like insulation material for the building envelope, as well as different applications that you may not necessarily think of, but turn out to be extremely good use cases. And one of those applications I'll talk about later is a cell-to-cell thermal barrier for battery packs. So this is kind of what the aerogel looks like. It's a very translucent material, and it's often described as kind of like a solid smoke type of material. So you have something that looks basically like a cloud, but in a solid form factor. And some of the utility there, and one demonstration I like to do, not necessarily in the lab setting because I've been called out for this, but is the blowtorch test. So you can see really, really thin pieces of this aerogel material, and I can take a little creme brulee blowtorch and have 100% confidence that I am not going to burn myself in this setting. So what our company focuses on is really on driving down the cost of production. So we see that this material is basically like considered one of the highest value materials. And what needs to happen in order for it to actually make an impact in the world is bringing down the cost of production so that we have a much more assembly line type production methodology. And what this ends up culminating is about a 90% drop in the cost of the material. So the way that we're accomplishing this is by looking into the traditional manufacturing methods and then just fixing all of the problems with those methods. So the transition there is basically like reducing the amounts of expensive equipment, the specialized training, and all of the bottlenecks that lead to a very high cost of manufacturing. And to give a little bit of background as to what the traditional manufacturing method looks like, it's a process that is called supercritical drying. So, in order for aerogel to have a very high insulation value, you're basically having like a very fluffy type of material. So, the way that aerogel is processed is it's almost like a jello formation. So, you start in a liquid form factor, you have a very porous matrix, and then you need to remove the pore fluid from that matrix without having the pores collapse. So you can imagine also like when you're doing your dishes, for example, and you put your sponge off to the side, if you're just kind of like leaving it there, it gets all shriveled up and nasty, and that is not good material. What we want to be able to do is remove that liquid without having the pores collapse. And the traditional way to do this is by using a supercritical dryer. The use of a supercritical dryer basically avoids all capillary tension on the pores, which are on the nanoscale. So by eliminating capillary tension, you are ensuring that the pores remain nice and fluffy. The drawbacks of this manufacturing method is that you have extremely high capital expenditure and it's very difficult to scale. You're basically imagining taking these little pressure chambers and trying to make them bigger and bigger and bigger. At some point, you end up in a situation where you just have basically these pressure bomb situations, which also results in very high safety concerns as well as just high cost of maintenance. And these are all really bad things that we don't want to be doing, even though we want our high quality insulation materials. So what we do is we take the individual steps for aerogel manufacturing and we reduce the cost at each step. So some of the work that we've done while participating during the cyclotron road program is driving down the cost of production just by exploring new precursors. So we kind of had a baseline going into this as to what makes a good high quality aerogel. But we also know that there are different precursors that are much cheaper that can also get good high quality aerogel. And this is the kind of R&D that like an investor doesn't want to hear about it, right? So they're just kind of like, oh, you have a thing, just roll with the thing. Don't worry about it. You can fix some of these fundamental problems later. And it's like, no, we want to be able to approach it from the perspective of being placed in a area where we are poised for success. So you kind of you can see these problems that are going to be downline and you want to be able to approach them before they become really big problems. And an investor is not going to care about that, but a space that's kind of really embedded in the academic perspective gives you the opportunity to optimize some of those components. And then the key to what we are able to accomplish is really in the solvent extraction part. And that is in the drying methodology. So the way that we remove the pore fluid without having the collapse of the pores and while maintaining an extremely nice and fluffy material. So what we do is a evaporation-based process. So because it's just normal evaporation, it's a very cost-effective type of process. And the equipment that we use is basically very similar to an environmental chamber. So if you're just imagining a box and you are flowing nitrogen through that box, that's kind of the process that we're doing. Some of the special engineering safeguards that we have in order to maintain the high porosity have to do with the nature of the solvent within the box. So I almost like to describe this as very similar to like a dehumidification process where you start at an extremely high humidity and then you very slowly ramp that down so that instead of having like that spongy material be shrinking in on itself, it's kind of maintains its nice fluffiness as the solvent is being removed from the system. So we're using a solvent that has a very low surface tension, so very low capillary tension on the pores, as well as a very high vapor pressure. So we can really control the rate of the drying dynamics on the micro scale as well as on the macro scale. So it's like the combination of these two things is the scientific innovation that goes into our process. The really nice thing too about this process is it gives you the opportunity to recycle things, the opportunity to really engage in the manufacturing process in a circular manner. So then that way you can take what would traditionally have been part of the waste stream and then funnel back that into your process, which is something that we are really excited that we're able to do with the manufacturing process that we developed. So we have insulation, right? So there are many applications where this can be useful. And one of the big ticket items is basically in fire prevention for lithium ion batteries. So lithium ion batteries, it is absolutely undeniable that they have a significant part in the way that we're approaching energy and the way that our modern society is building out its infrastructure. They have many significant advantages, but one critical hazard associated with lithium ion batteries is this idea of thermal runaway. So if the battery is experiencing a failure mode, it's basically overheating and it is eating up the electrolyte. So this electrolyte will catch on fire and you can actually reach temperatures that exceed 1000 degrees C very easily. And this is why these are extremely dangerous types of fires. And lithium is also water reactive. So the traditional means of basically tackling these types of fires are not as effective as they would be for different types of fires. So one method for mitigating this type of risk is by incorporating a barrier that prevents the fire from spreading and propagating to other batteries. So what you want is a small part failure, not a cascading catastrophic failure. And that's really where aerogel can come into play. So right now, the aerogel-based thermal barriers that we make can basically be placed in between cells. This is particularly useful for flat form factors. And they are highly heat resistant as well as have an extremely low thermal conductivity. So this gives you the opportunity to prevent the heat from transferring between battery cells. Our future work is also focused on really driving up that heat resistance component just because lithium ion fires can reach 1000 C and that's not currently where we're operating. However, this is good enough to like really get the ball rolling and really get conversations going. And in the customers that we've tried to initiate conversations with, one of the number one things that they're worried about is the cost component. So this has a lot of utility within electric vehicles and transportation vehicles in general. They are counting pennies. So this is a really big piece of equipment and they don't want this individual small part to basically eat up their budget. So the fact that we can offer this type of product, which they've already been familiar with because other companies have kind of really started. There's other companies that are a little more established that use different manufacturing processes, but they've done the heavy lifting in terms of educating these customers. So that's kind of some of the perspective that we're taking in that when we drive down costs, the customer's already educated. We are a drop-in solution for what they already know is able to work. And taking that perspective, our long-term customer goals is more on the electric vehicle battery side. But we are cognizant of the fact that data centers are a big selling point right now. And that's something that is a growing industry and gives us also the opportunity to add the same types of benefits that you can see in electric vehicle battery state. So some of the perspective that we've been taking recently is really looking to the infrastructure associated with data centers, which there's regulations surrounding like fire prevention for a data center. And if you have that like fire barrier type product, what you can basically do is reduce the footprint for your racks. So like you can have more racks stacked in a smaller space because you have this fire barrier product that is basically keeping the surrounding area safe. And that's something that we want to be able to provide and we want to be able to use to help basically facilitate the trends that we've been seeing today. And then using that as a platform and as a testing validation market, then we can expand to the electric vehicle market, which is a really high volume, but you're counting pennies kind of market. So that really requires us to be able to meet some sort of economy of scale perspective with this material. Just to kind of give you guys an idea of where we are. So the way that we fit into a supply chain is we can either interact with the original equipment manufacturer themselves, so people like Volkswagen or Nissan or GM, or we can also interact with the tier one suppliers. So these are the guys that are making the parts that then get sold to the OEM. And we've had a pretty even spread between conversations between the two types of groups, with a little bit more heavy emphasis on the tier one supplier side, just because that's really where the aerogel can fit into that manufacturing and basically the supply chain for these types of products. But we've also had pretty significant conversations with like Volkswagen, for example, and they seem extremely excited to kind of see where the company is going and where this technology might be able to like fit their future needs. And I mentioned that there are actually, in fact, other companies that make aerogel. So this is not a novel technology in terms of the material. This is a novel technology in terms of the way we manufacture it and the way that we can make extremely high quality product affordable so that aerogel can become a ubiquitous insulation material. Kind of summarizing some of the things that our company focuses on and the overall value add. We want to be able to manufacture the aerogel in-house. So this gives us the opportunity to this gives us the opportunity to become the domestic supplier. So we want to be able to be like the number one aerogel people within the US. The way that I kind of try to describe it is you're thinking of a company like a Dow Chemical, for example, where they have like a specialty material, but then they have all these products associated with that specialty material, and it kind of expands outwards from there. Another thing that doesn't make it into these slides just because of the nature of where we are politically right now is that I am very interested in ideas of like circular economy and much more regional manufacturing, because that's just like an absolute obvious no-brainer. Like you should be able to take waste streams that are local and regional to you, take that and put that into your supply chain and incorporate that as part of your manufacturing process. And that's something that I hope to be able to spend more time developing as the company continues to grow. Giving a little bit of an overview on our timeline. So I started the company immediately after graduating from UCLA. So I got my degree in material science at UCLA. And in this, for my founder journey, I was very much encouraged by the program director at RPE to apply to the Activate program. So it was kind of like I had a conversation with the program director, I remember, and I was telling her that I was interested in exploring the idea of starting a company and really what it means to be an entrepreneur. And she very immediately referred me to the Activate program and the Cyclotron Road programs. So that was kind of more of an eye-opening experience for me in that it's an actual viable option. Because when you're like in academia, they really only tell you that there's industry and there's academia. And you go into a PhD program thinking you're going to go and do research and you're going to continue the academic journey. But then you like reach a point where you just really want to see the work that you've done have an impact. So I joined the Activated Cyclotron Road programs in 2023. And then I almost immediately got the CalSeed Award, followed by NSF Phase 1, and we're currently waiting to hear back about NSF Phase 2. So that is basically all that I have for you guys. You can see our smiling faces. Here's my team. And with that, I would love to open it up for questions.
Excellent. Thank you very much, Patricia. This is really cool. Yet another story of success here, right in our backyard, right here in Berkeley. It's awesome. Incredible. So let's see if there's any questions or follow-up comments here for Patricia. Looking around here.
All right,
Go ahead.
I seem to be
Marcos,
leading the charge here, but
you can generate
I
some
think maybe I had too
excitement
much
here.
coffee today. But I love your enthusiasm. I love your excitement, and I love that you're incorporating what your competition is and where you fit and how you're going to compete. I think that so where along the way did you develop that portion of, okay, I've got an idea, but how do I fit that idea into what it's going to be as a company and can I make this work? You got to understand your competition and where you fit within that. Where along the stages did you kind of feel comfortable, like I've got the idea and the plan down?
Right, right. So let me go a little bit more into my overall like technology growth story because what was originally funding me during my PhD was working on making the aerogel extremely transparent for window applications. So like the Department of Energy is really excited about the idea of aerogels being a retrofit solution for single pane windows, where it's like you slap an aerogel another pane and you have instant double pane performance. And I think for me, this is definitely part of that entrepreneurship journey because I was kind of like seeing who else is working on the transparent insulation. You could tell there are also other alumni activate companies that do a really good job with this. So it's kind of like, where's my thing and what is it that I have to offer? And that's not necessarily the transparency component. Like what I was offering was the fact that I was able to make a lot of stuff very quickly and at really high quality. So the thing for me was just kind of trying to figure out where is economy of scale really important, considering this is already a high performance material. So that's kind of the mindset that I was trying to come at it with. And that ended up being, as I was doing kind of like general market research, the EV market overall, because that was the highest growing market. That's where you really see the scale. And the comparison in terms of competition is so like our big competitor for the US, they're called Aspen Aerogel. And it's kind of like you look at their journey and you can actually even do like one-to-one comparisons. It's like, what did they do? Where are their strengths? Where are their weaknesses? And what can I do to like demonstrate that my manufacturing process and my technology has something to offer that's really separate from what they're doing? So that's a lot of where my mindset is when I'm thinking about like the aerogel and where it fits and where I can actually, make my impact.
Mm.
So
Okay.
chicken or egg. I
Kind
mean,
of
so
rambled there.
you like
Yeah.
in the process, we've seen like the battery storage for vehicles and things of that nature
Mhm.
was kind of eclipses this last decade, but just moving forward, the last few years has been about the energy resources going to be had to be dedicated towards data science and
Yeah.
these centers that are going to require a tremendous
Mhm.
amount of energy. So did it shift your focus because that you're going away from like a relatively decent growth pattern to like an accelerate like exceptionally accelerated field? I mean, did that happen in the process? You started with one and kind of like maybe shift your focus to the other?
Yeah, it's a continuous process for me, I think, because since aerogel is a platform technology, like there are so many applications that as long as I'm not like distracting from the core R&D, I am happy to provide it wherever it has the most value. And that's really where the data center component comes into it. It's like you see that there's value to be added there, and there's no reason not to offer that value, in my opinion.
Okay. Melanie, you had a hand up there. Did you want to comment?
Oh yeah, I was just going to ask Patricia to share, what your journey is looking like in the coming months because you are in the cohort that's graduating, and so I know that that is like you took time out from your move out process to be here today, so thank you for that.
Of course, yeah. So we are currently moving out of the national lab. I'm part of the graduating cohort. And where we're at is basically we really wanted to, in the outgrowing the national lab process, like build out our pilot manufacturing line. So we are really excited to kind of like dedicate this space to having like semi-continuous automation, really increasing the volume of production that we can do. And we're also excited to just like be able to fundamentally design a space to be able to fit that. So it's not kind of like shoehorning into a pre-existing space, which obviously I am extremely grateful to the Cyclotron Road program for giving us the support and the resources to be able to take off. But we're also extremely excited to like really see the growth component for the company and designing out our manufacturing process with that. So right now we're actually focusing our attention on Gate 510 in San Leandro, and that seems to be like a really good spot for us. And it also has like some opportunity for growth spaces. So we've already kind of like looked at places that are closer to 10,000 square feet, and we're like, yeah, that sounds exciting. We can fill that up with stuff.
Okay,
Thank you.
very good. Any other questions or comments for
Just
Patricia?
congratulations. I mean, it sounds like it's going to be a great launch.
We're very excited.
All right, things are happening right here in Berkeley. Where is Cyclotron Road, by the way, Jen? Could you just, I mean, where's the physical road that has that name on it?
I can
I was
answer
gonna
that
say,
one.
Melanie, I'm gonna let you
Yeah,
take that
so
one.
if you head uphill on Gailey, is it Avenue or Road? Gailey
Gailey
Road.
Avenue.
Avenue. Okay, so
It's like Gailey and Loloma.
yeah,
Like if you, yeah.
if you were just heading uphill on Gailey and you pass, the UC Berkeley buildings that are on that, East Gate side, or is that North Gate? Ugh, it's
Yeah.
so confusing. I'm directionally impaired. Anyway, you just keep going uphill and it turns into Cyclotron Road and you enter at the main gate. And so when they were trying to come up with a name for our program, the idea was,
Mhm.
there's Sand Hill Road, this is Cyclotron
Right,
Road. Yeah.
right, exactly. The famous Sand Hill Road. I get it. It's a
And sorry,
nice
Daniel, were you thinking
compliment.
like where does Cyclotron Road have its headquarters?
Well, both, yes. I was
Okay.
thinking the actual road, but where are the activities
So the
located?
fellows
Yeah,
are all over the lab at all the facilities that they're working at. So,
I see.
yeah,
We
they're
have a small headquarters in Building 62, which is pretty near the Molecular Foundry. And then we do have some teams that are also working out of LBL rented space down in West Berkeley, in kind
Mhm.
of the biosciences area. And then we do have teams that are embedded in various different research areas and user facilities.
Mhm. Well, I'm getting the picture. Cyclotron Road is kind of like a state of mind. It's wherever you happen to be.
Gonna make that t-shirt.
Yep, there you go. Okay, well, thanks again. Let's give a hand to all of our speakers once more to wrap up this evening's session. I was just going to quickly flash on the screen that we do have a calendar of events just for your date books. Remember, next meeting, March 9th, then we have June 8th, September 14, and November 9th. So make sure those dates are in your calendars because we will have more exciting things to share with the CAG and also get your friends and neighbors interested. We're open here to have more members of the Berkeley community join us and our neighboring cities as well. And so they can contact Jen about potential to bring some new groups, new energy into the CAG process. So with that, I think we will wrap up this evening. Thank you all very much for joining us once more. And thank you for all of the great work that's going on. It's really exciting. The lab is definitely a hub of innovation right here in our backyards. All right. Take care, everyone. Good
thanks
night.
everybody. Have a good night.
Cheers. Yep. Bye-bye.
Thank you. Good night.